What's up YouTube? Welcome back to another Godot game development tutorial. And in this episode, we're going to kick off our top-down series. So if you want a sneak peek of what we're going to do in just this first episode, we've got our little character right here, and we're going to be able to move in all four directions. And I've got a little tile map in there. So yeah, we're going to be covering various different topics in regards to top-down. And the way I'm going to kind of take this game is we're kind of push it kind of like a roguelike. So, player go into randomly generated worlds, collect loot, fight enemies, die, respawn, kind of that thing. Simple mechanics, but we'll be able to talk about a lot of different game mechanics in doing that. So first thing we're going to do is we're going to create a blank project. This is 4+, save it, and then I always move my structure like this. So file systems here, scenes, import and history, and then the inspector and node are right there. And then for my resources, I used to do like a separate assets and entities, and I really don't like that. I like to keep all the assets relative to the code. So I have my entity, my player, my assets. Like in here I can also put the scripts that are relevant to the player. I've got my scenes, the world, the assets. So like I can move my player sprite there, and we can move tiles into that. And then icon, just project icon. Some project settings we're going to get into. So we don't have a main scene yet. We will get to that. We are going to set the max FPS to 60 and hit enter. And then boot splash, we'll leave that as is. Go down to window. We're going to set this to 640 by 360. Okay, and then I'm going to go viewport, ignore aspect ratio. Perfect. And then because we are doing pixel art, we'll come down to rendering, textures, and set this to nearest. And that will get our textures nice and crisp. Perfect. Let's head over to the input map, and we're going to add in some actions. We're going to do up, down, left, right. We'll call this attack and dodge. So this will kind of be like enter the gungeon style, so we're going to do right mouse button is like your dodge, left mouse button is your attack. For now, at least, maybe we'll switch it to spacebar dodge, and we'll add like a close range and a long range. We'll see. I'm not set on that exactly. That's just how I have it set up for now. So W for up, S for down, A for left, D for right. Attack, we'll do left mouse button. Okay, and then dodge, I'm actually going to bind two. Let's actually bind space and right mouse button. So either one of those will work. Maybe we'll remove right mouse button. We'll see. I mean, you can always map controls how you want anyways. Alrighty. So there we go. We have that. Perfect. So this is going to be a little different in the sense that well, it's going to be a little different in the sense that because it's a roguelike, we're going to code this from the beginning so that multiple characters can be used. And so like the player can choose different characters with different stats. That's what I mean by that. And so the way we're going to do that is through what's called resources in Godot. So I'm going to create one more folder, call it characters. And in here, we're going to create a script and call it character.gd. Create. Perfect. Let's open that up. And we're going to say So this extends resource, and it's going to have a class name of character data. So if this is your first Godot video you've seen from me, extends is saying what type of Godot object this script is gonna like get its properties from, and this is resource. A resource is literally, it can be so many different things. Imagine the best way to think about it is it's literally just data. It's just data. It can be sprites, it can be sounds, like my audio engine that I've made and uses resources, and the resources are just like settings for the sound and wrapped around an actual audio file. So it's just data, and it's data we can customize in a file and kind of name that file something, and we name that file character data, just like that. So we hit save. And then what we're going to do is we're going to add an export category. So call it graphics. And we're going to add one more export category right here. And this will be called movement. It's really important to keep that O capital right there. Just kidding. Well, we got rid of the M2. Movement. Cool. And so what an export category is, like when you click on something, see how we have resource and then ref counted? Those are export categories, and those are exports. So like now if I go and export variable sprite, and we call it, or we make it of type texture 2D, and then not a capital F, float 100.0. So I always make my constants camel case, so like capital for the first letter of each word. The reason I'm not making it constant here is because we actually change it. So I use it like a constant, but I have to set it outside of here, and so I can't actually use a constant. But like in my head, I'm like, okay, this is a constant. Alrighty, perfect. So we have that. Now what we're going to do is in characters, we're going to create a new resource. And if we go in here and we start typing character data, we see how that pops up under resource. Click on that. We're going to call this cloak. We'll save that. And now if we open cloak, see it opens this right here. And I can edit this. So I can make the walk speed 150 or reset it back to 100. So notice that's the default value, 100. And the default sprite is empty. So I can go up to my player assets and drag that down right there. And now my character has a sprite and a walk speed. So basically, we're going to code the player script exactly how we normally would, except for in like the initialize. So like the very first loop in when we're initializing everything, we're going to set all the variables that need to be set instead of setting them like up top in the file, and then we kind of have to pass that information in. Sounds a little confusing. It'll make a whole lot more sense. All right, so we got characters, scripts, perfect. So let's create a new scene, call it player, and we're going to character body 2D is what we want. Perfect. Okay, so then I'm going to add a whole bunch of nodes here. So first off, we're going to add a sprite 2D and just call it sprite. We're going to add a collision shape 2D, call it collider. We're going to add a camera 2D, call it camera. Add an animation player, call it animator. Call it whatever you want. These are just what I like to call it. Okay, perfect. Okay, so now let's go into our collider. And what we're going to do is we're going to make it a capsule shape. Okay, so you'll notice that we're going to drag this player script in here real quick. And I think it's 12 by 9. Okay, now let's adjust the capsule. Cool. Cap, so that's adjusted. Sprite is there. We have our animator. Okay, and we're gonna need to add a script. Call it player.gd. Perfect, extends character body. So let's knock out this script and then we'll go add in the animations and then we'll go to the world. Okay, so extends character body, class name, player controller. Perfect. So first thing we're going to do, I always add regions to my code, makes your code much prettier. And we're going to add in our collider, our sprite, and our animator. Perfect. So what these regions do is it just makes it so you can fold it just like that. You just start saying region, give it a name, and you type, comment end region at the end. So this will be player physics. And we're going to add an export variable, lowercase p for player, and this will be of type character data. And then walk speed. Remember, we can't set it because we need to set it later. Input direction vector 2.0. Moving direction, also a vector 2. Set it to vector 2.0. So these will be for like our player's input direction and then which way we're facing. Got our 2 there. Yep. Oh, there we go. Okay, perfect. And that region. And we'll go to our ready function. So first thing we're going to do is we're going to say walk speed is equal to player.walk speed. So remember, player is the character data. And so we're saying, hey, whatever character data is assigned currently to this player controller, grab that information from there. Same thing with this. So the sprite's texture is going to be the sprite within character data. So sprite, walk speed. And remember, in cloak, we've set it to this sprite sheet. Okay. Function, physics process, perfect. First thing we're going to do is get our inputs. We'll write this function in a second. And we're going to say the player's velocity is equal to walk speed times input direction dot normalized. So this is important. A little bit of trigonometry. Let's pull up good old A sprite. Okay, so there's our grid. So if I hit, the up key, that's my input. If I hit the right key, that's my input. And if I hit both, my input, is a square technically. Oh, we're slightly off on that. Boom. Does that make sense? So if this is length 1 and this is length 1, this right here is actually length 1 root, 1 root 2, because that's a 45-degree angle, that's a 45-degree angle, that's a 90-degree angle. So what normalize does is it basically takes whatever the vector is and sticks it on the unit circle. And so instead of our vector being all the way out here, because it's 1 and 1, 1.2, it basically, just takes the sine and cosine of that, or the tangent, and it gives us a vector that looks like that. So That's one, that's length one, that's like one, instead of that being length 1 point, or like 1 root 2. If you've ever coded like a 4-directional game and you notice you move faster in diagonals, that's because you're technically moving at 1 root 2 speed instead of 1. So we have to normalize the vector, meaning cut it back to 1, so that we get, you know, smooth inputs even if we have multiple input directions. Yeah, so if you ever thought math wasn't useful, math is incredibly useful, especially in game programming. Okay, so some utility functions. First up is get inputs. So that's the one that we've already called. We haven't coded out yet. So we're going to say input direction is equal to input dot get vector. And we're going to do left, right, up. Yes, it does matter this order. If you flip it, then your inputs will be flipped. So just make sure. And dodge. No, down. Perfect. Okay. We're going to code this in right now, and then we'll explain it in a second. So this is going to be for animation and making our lives a little bit easier when we do animation in 4 directions. Sorry, a lot of typing. We're going to get a lot of red right here because we haven't defined a lot of these functions. But this is handling our animation. Essentially what it is, it's saying if the velocity isn't 0, so we're moving, play an animation, and then this is a function that'll basically say, it'll basically return, you know, the walk animation, and then it'll add on to the end underscore, like, you know, left, right, up, or down. So instead of like calling it all differently, we just have one function that returns the proper string name of the animation based on the direction. And once we write this out and we add our animations, we'll go back and take another look at that so you can understand that, because we want to make sure that that is understood. Okay, now these are all, we're just literally going to grind. Yeah, we're literally just going to grind through this because we need a way to know which way the player's facing. So like if you hit up, we want them to stay looking up, or left, stay looking left. And that's what this is. Facing direction equals vector 2 dot up. Okay, and I'm going to be lazy and copy and paste the rest of this. So up, down, left, right. Perfect. Let's end the region. Add another region for graphics functions. Okay. We're going to add in a function called set sprite flip. So if the facing direction is left, set the flip to true. If it's right, set the flip to false. So that's just, we have 3 animations, up, down, and to the right. And for the left, we just flip the animation because I'm a lazy artist and don't want to draw art for the left and right. So that's a quick little function. Alrighty, then the last function we're going to do here is this one we will type out. So this is get animation direction. and it's going to return a string. Okay. So what we're going to say is if our input direction is not equal to 0, oops, it's not equal to vector2 dot 0, because it's a vector, can't compare it if it's not a vector. We're going to match the input direction to the following cases. So first, vector2 dot up, in which case we're going to return name plus up. Okay, and we're going to say vector2 dot down. We're going to return the name. So this is like the name of the animation, so like walk or idle. And then we're going to add on to it, in this case, underscore down. And then we're going to add this symbol, which is like the default case, so everything else will just return name plus side, because we just have side. Now, if you wanted to, we could add like a left and a right, and then also, set the direction like we did right here. I just wrote that as a separate function in case we need it in other places. But feel free to tweak around with that and see if you can get it to work that way. I'm sure it will. So else we're going to match based on facing direction. So if we're not moving, we want to face based on our facing direction. If we are moving, we want it to be based on the input direction. So up is going to return same exact thing. Name plus underscore up. And then vector2 dot down. We're going to return name plus underscore down, one, and then same thing, default case, return name plus underscore side. Alrighty. There are all of our functions. Our physics process. Is that supposed to be underscore delta? Is that why it's yelling at us? Yeah, that is why it's yelling at us. That means it's like a local variable, so like we can only access it in here, which is why I also did this as an underscore name. Fun fact if you didn't know that, otherwise it is yellow and yells at you. Alrighty, so the code is there. If we run the game though, nothing is going to happen because we can't see anything and we also don't have a world scene. So let's go ahead and move on to adding in the animations, and then from there we'll go talk about like the tiles in the world. Alrighty, let's open up the animator and go to manage animation. Actually here, let's go to new. We'll call it idle down. Okay, now we'll go to manage animations, and we're just gonna add a whole bunch of new ones. So idle down, idle side, and then idle up, and then same thing for walk. Walk down, walk side, and walk up. Now for these, you can name them whatever, just make sure that idle, walk, and downside and up match the code for walk, idle, and returning up, down, and side. Those have to combine to match what our animations are called. Otherwise, you're going to run into a whole lot of problems. Okay. So we're going to start with idle down. And one of the, I guess, flaws of this system, it's a simpler system, but it requires that every different character we have has the same exact number of frames per animation, which honestly really isn't hard to do. Chances are if you animate a player, you're going to use the same exact frame for each player, just change what the player looks like. So it's not really a big issue, but that is a downfall to this. Excuse me. That is a downfall to this system. So if we go over to Sprite and we start keyframing here, we are going to add in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12 frames. I'm going to make this 1.2 seconds, and we're going to put a frame every tenth of a second. And I do think I actually have the number of frames wrong. I think, yeah, because see we have a double there. I think the code I'm looking at was I started working on like another version of this project, and so it's like freaking out a little bit. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, that's an extra. Goodbye. Technically, also what we have to do is we have to go back here and we have to reset that. So, yep, perfect. So we just want frame numbers. And this should start at 36. So 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, and 47. All right, that's idle down. Now we just have the great joy of repeating this again and again for each of these animations. So we come here, we go to Sprite. We'll actually make this easy on ourselves. So this starts at 48. So we'll keyframe 48. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Make this 1.2. And then drag these out. If you want to make it even faster, you can go down here and switch that. So that's lock it to the nearest tenth. So that way, you just drag it and it'll put it right where it's supposed to be in terms of 0.1. Perfect. And then we go to idle up. Idle up is going to start on frame 60. So we go to Sprite, 60, perfect. 1. Let's switch this to 0.1. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Oh, whoops, I deleted that. Okay, we need to... Yeah, so that's 61. That's 61. It starts on 60 though, right? Yeah, 60, 61. Okay. Perfect. Lovely. Okay, so now we go to walk down. Switch this to 0.1. Walk down starts on frame 72. So we'll go to 72, add keyframe. And this one only has 6 frames. So we go to 0.6, and then move to the next animate. Okay, walk side starts on 84. So we'll go to 84. 4, switch this to 0.1, keyframe that, and then, yep, there we go. Yeah, so in case you're not following along, that's the animation length right here. This is snap, so to 0.1 second, so that's why it's snapping to this. Just makes, doing things like this much faster. Okay, so walk up starts on 96, snap to 0.1, and then keyframe, it's 1, 2, 3, 4, 5, 6, perfect. Switch this to 0.6, and there we go. All of our animations are in store, so we can close down the animation editor. We can go to our scene. We're not going to see anything, obviously, and let's create the world scene. Talk about tile maps a little bit, and then get everything thrown together and hit run and see what's broken and fix it. Alrighty, so create a new scene of just node 2D. I'm going to call it arena, and then we're going to add tile map layer. Call this ground, and then for starters, where's just a node 2D? I'm going to call this Y sort. So this will just be like a way to sort our Y sort. So Y sort is like what lets certain things in 2D games be on top of the other. It's like you're behind a tree, but then if you walk like in front of the tree, you render on top of the tree. That's Y sort. I'm sure there's a better way that we'll talk about this and we'll look into it. This is just a really simple way of getting it started off the bat. Okay, so yeah, ground, player, trees. Okay, real quick, in player, see how this says empty for player? This needs to take a character data. And so we're going to go to cloak, drag that info in right there. Perfect. Now, if we run, we can hit select current. And we can see our character, and all kinds of crazy things are going on because, like I said, I dragged in the wrong image. There's not supposed to be, this is the sprite sheet for the next project, so video 2, so it's got an extra animation in there. Not a big deal. We just need to mess with these numbers. Give me 1 second. Okay, 12 and 12, I believe, is what we're looking for. So now if we run the game, there we go. Run, idle, run, run. Yeah, so 12 and 12. There we go. We can also, get our aspect ratio and everything going. Sweet. So our player runs left, our player runs right, our player runs up, our player runs down, the idle down, the idle left, the idle right, and the idle up. Perfect. So the last thing we need to do is talk about tile sets. So let's talk about tile sets. Over here in world, we are going to create a new asset. And this is going to be a tile set. Perfect. We'll just call it tiles. Yep, hit save. And then we're going to open that up. Tile shape square. Perfect. 16 by 16. Perfect. Physics layers, we're going to add a physics layer. 1 and 1. Perfect. And then we're going to go into terrain sets, and we're going to add a terrain set. Okay, terrains. We're going to add an element. We're going to add this first one. We're going to call grass. Now, somebody I'm sure is going to watch this and be like, dude, there's a much better way to do this. If so, please, please, please tell me. I actually am not very good at terrain sets. I find them very hard and finicky. And so if somebody knows a better way to do something, I'm all ears. This is just me trying to explain to people best I can what I know to help them on their journey. So you're going to be really confused about this. Just hang in there. We'll explain it to the best that we can, and hopefully it'll make some more sense. All right, drag in tiles. Make tile sources. Perfect. Don't need to add any collision map to any of these because no, we don't really need to. Okay, perfect. Okay, that's all good there. Yep, okay. So now, if we go to Arena, and we go to Ground, we can drag on the tile set, perfect, and now we have this tile map. Actually, hold on, we're gonna go back to tile set, my bad, I lied. Nope, it's in tile map. No, we need to go to tile set, what am I doing? Okay, there we go. Sorry. We go to paint and then property, terrains, select terrain set 0, and we're going to select grass. So what this does is it essentially lets us paint properties. And so we're going to paint like parts of a tile, and that'll help the tiles know what connects to what. First thing we need to do though is we need to go back into this, and in terrains, match corners and sides is what we want. Perfect. Okay, we go back over here. We're going to select all of these tiles because all of these are going to want to be selected. And now see how we have this right here? So everything that's grass, we're going to go and select all of that. So we're going to go on the perimeter here. And then we're going to go on the perimeter here. And then also in on these corners, just like that. Same thing here, perimeter. And then in, just like that. And then here, it's going to kind of be the opposite. Like that. So that's dirt. So it's like the inverse of that. And then same thing here. This is basically just going to be a rectangle. And then this is also basically going to be a rectangle. So this is for auto tiling. And basically what Godot does is using like where we're coloring these things, it makes sure that green touches green and brown touches brown, if that makes sense. And then these are all grass. Perfect. So now we switch this over to dirt, and everything else is dirt. So that's all dirt. That's all dirt. This is all dirt. Like I said, I'm not the best at this. I know a lot of people use like a plugin for tile maps because Godot's tile map system is pretty good, but still kind of finicky in a lot of ways. So I know a lot of people, there's a plugin that a lot of people use. I forget what it's called. And apparently it makes it much easier. I haven't looked into it. I'm trying to make everything, and especially in these tutorials, you know, as pure Godot as possible. And I'm sure Godot, they might update it, or maybe it is really good and I just haven't put the time in to know how to use it super well. Okay. Perfect. I think we're good there. Yep. Okay. So now if we go to ground, we should just be able to place grass. And then if we select a path, there we go. Yeah, see how it automatically does that? So let's do this. Let's go grass and just make like a massive rectangle of grass. And it's going to take a second to fill it in. Perfect. And now we can just go to dirt and just draw a bunch of paths. And see how it's like auto connecting everything? That's exactly what we want. Oh, okay, I guess we're making a triple up there. And this one will go here. And then it'll connect back in here. La-di-doo-dah, we'll make one up here. Make a short path right there, connects in up here. Perfect. So now if we run the game, we can see our character, and we're running. Whee! And we've got our map. Oh, little glitch right there. Little glitch right there. Okay. So that means we've colored something wrong. Let's go check our paint job. And tiles, tile set, paint. Where would those be? So that's up here. It's a rounded corner. It's one of these corners, I think. But based on my reference project, that is correct. That's how I have it. Maybe my reference project is slightly broken too, and I just haven't noticed. It's very possible. Well, we'll figure out how to fix that, and we'll fix it in the next episode. But there we have it. We've got a fully functional game. Very brief bones. So we've got, we'll keep the aspect ratio. We've got the basics of our top-down game where we've got a player. He's running left and right. He's running up and down. He's got animations, and we've set it up so that we can add multiple characters. So yeah. Next things that we're going to talk about in this game is we're going to talk about adding like a dodge mechanic. We'll talk about adding, like a gun. We'll add a gun first because why not? And then quickly after that, we'll add like an enemy, probably like health, points, treasure. We'll get like a score system going pretty fast. And then we can talk about adding, more advanced attacks, more characters, etc. So if you're not subscribed, go ahead and subscribe. If you like this video, drop a comment, leave a like, and I will see you guys in the next one.